Welcome back. This video is part 2 of the density lesson. So now we're going to get into actually calculating density for different materials and other types of questions that you might see for this lesson. So density can be indicated in two ways. The first is mass density. Remember we were talking before how density is equal to matter over volume, and matter can be mass or weight. Well, those are the two ways that density can be indicated, either mass density or weight density. Let's look at mass density first. Mass density is mass per unit volume. So density of mass equals mass over volume, or with simple variables, we have D equals M over V. Or you can algebraically rewrite that to be mass is equal to density multiplied by volume. And mass is measured in grams, G. Volume is typically measured in cubic centimeters, centimeters cubed, and density, therefore, is grams per centimeter cubed. And mass density is most used when working in metric. Another way of wording that would be we rarely use mass density for English. Mass density is mostly for metric. And then the second way would be weight density, which is weight per unit volume. And in this case, it's going to be the density is equal to W over V. Again, you can algebraically rearrange it. And weight is going to be measured in pounds, volume in cubic inches, and therefore density is pounds per cubic inch. And likewise, weight density is most often used when working in US. We rarely use weight density when working in metric. You could though, right? I could say that the weight density for metric would be newtons per centimeters cubed. And I could say that the mass density is slugs per inches cubed. You could do that. You just don't see it as often. So here's like your summary slide for all your equations. Here are like your 6 formulas. And these formulas, like these 3, are all the same. These 3 are all the same, meaning you can use any one of them in your question. However, it is easiest to use the one that has what you are solving for by itself. For example, if I know the volume and I know the density and I want to get mass, I'll use this one. If I know the weight and I know the volume and I want the density, I'll use this one. If I know the weight and I know the density and I want volume, I'll use this one. So whichever one you're looking for, use the one where that one has it by itself. So here's a chart which shows you densities for relatively common household objects. Like water is the base unit. The water has a mass density of grams per centimeter cubed. Gold is 19.32. Apple, kind of random, is 0.64. So which material has the largest density and the smallest density? And does that make sense? Well, the largest density would be gold, 19.32, which kind of makes sense, right? Metals are pretty heavy for a given size, and apples are relatively light for a given size. Like if you have the same size, take the size of an apple, and then if you fill that up with, I don't know, sand, you imagine that would weigh more. So yeah, I think that makes sense logically. Okay, let's look at an example. What is the weight of a 3-inch by 4-inch by 5-inch block of aluminum? So let's talk about how to solve it first. We are looking for weight. We know or could find out the volume, and we know or could find out the density. So step 1 would be find the volume. Step 2, determine the density. Step 3, calculate the weight. Find the volume of a rectangular prism. I would just multiply the length times width times height. 3 by 4 by 5 equals 60, right? 3 times 4 is 12, yeah. Now let's look at the chart again to find density. Since we are working with US units, let's use weight. We have aluminum, weight density. We know that we have the density is 0.098. And since we are looking for the weight, we will use the formula that has weight by itself. So I'm going to multiply my volume by my weight density. 60 inches cubed times 0.098 pounds per inches cubed. Inches cubes will cancel out. So I am left with 5.88 pounds. So that block, that 3x4x5 block, would weigh 5.88 pounds. Let's do another example. A slab of concrete has a mass of 3,000 grams. What is the volume? So in this one, I know the mass. I am looking for the volume, and I could pretty easily find the density by using that chart. So step 1 would be find the density, and step 2 is using the given mass and the determined density, we can use the correct formula to calculate the volume. So we'll look at the density chart. We are working with grams, so that should tell you mass density. So I have 2.4 grams per cubic centimeter. We'll use this formula because we are looking for volume. So I'm going to take my mass and divide it by the density. Grams cancels out. Centimeters will come to the top. And I am left with 1,250 cubic centimeters as my final answer. Example 3. What is the density of a 2.24 inch diameter sphere of titanium that weighs 0.82 pounds? Now, in this case, I don't know the density. That's what I'm looking for. That's why titanium is a material that's not on that chart. But if I know the weight and I could find out the volume, I can guess or estimate or calculate what the density is. So in this case, I'm going to have to first find the volume of the object. And once I know the volume of the object, I can do the formula D equals W over V. I have a sphere here. And we know, or could easily look up, that the volume of a sphere is 4/3 multiplied by pi r cubed, where r is in radius. However, this example gave you the diameter, not the radius, but you should know that the radius is half of the diameter. So I'll do 2.24 divided by 2, and that'll give me 1.12. So 4/3 times pi, or 3.14, multiplied by 1.12 to the third power, and here is my volume. I'm not looking for volume, I'm looking for density. So now I'm going to say that my density equals my weight over volume. So 0.82 divided by 5.88 gives me my final answer of 0.14 pounds per inches cubed. Now part 2 of this problem is asking me what volume of water would it displace. So imagine you get this little piece right here and then you put it in a graduated cylinder. You want to know how much more milliliters of water the water level would increase by. So I'm going to convert this to milliliters. And milliliters, surprisingly, is a volume. So that's okay to be able to do that. So if I have 5.88 cubic inches, I'm going to convert that to milliliters. Liters is a volume. So I'm going to just do some quick conversions, and you get 96 milliliters of displacement. You could get these formulas on your formula sheet as well. Okay, let's go on to the next topic. Have you ever bought a food item that you needed to shake well or stir before consuming? Probably, right? An example might be Italian dressing or natural peanut butter. Now, why do you have to shake or stir some items but not others? Well, the reason is items that have different ingredients with different densities will actually separate over time. Ingredients with heavier densities will sink, while the lighter ingredients will actually rise to the top. So this is an Italian dressing, right? What's on the top and what's on the bottom? Well, the top is actually oil. And this layer right here is going to be your vinegar and your water. And why does it separate like that? And why do you have to mix it up? Because the density of oil is different than the density of vinegar. Oil has a density of around 0.9 grams per centimeter cubed. Vinegar has a density of, I'd never change that, let's fix that right now. Don't look. 1 gram per centimeter cubed. And because oil has a lighter density than vinegar, it will rise to the top. Natural peanut butter, the one that doesn't have hydrogenated oil, when you first open it, the peanut oil is all at the top and the peanut butter is at the bottom. You have to stir it. Why? The density. The density of the oil is less than the peanut butter itself, meaning that it will separate. You have to mix it together before you consume. And this is just an example of how different materials, different densities will separate into layers over time. They have a ping pong ball, which is really, really light density. Lamp oil apparently is light. Rubbing alcohol, dish soap, milk. Like these, if you put all these into a giant bowl and then mix them together and then pour them into here, over time they would separate into these layers naturally. Kind of cool. So this is a reference to the movie It, if you ever saw it. But basically, how do we know if an object will float or sink? It has to do with the density. So water, again, has a density of 1 gram per cubic centimeter. Objects that are more dense than water will sink, and objects with a density less than water will float. So think of when you go swimming. Would the following objects sink or float? A pool noodle, a penny, a rock, a ping pong ball, ice, tennis ball, paperclip. Think about it for a minute, pause the video, and guess if it would sink or float. On the next slide, we will look at the actual densities and then compare it to water to calculate if it will sink or float. So pool noodle has a really low density. Remember, water has density of 1 gram per cubic centimeter. And if it's less than 1, it'll float. If it's more than 1, it'll sink. So a penny has a pretty high density. That'll definitely sink. A rock, they can vary depending on the rock, but rocks in general will all have densities greater than 1, so that'll sink. Ping pong ball is pretty light. It'll float. Ice actually is less dense than water, even though it's made of water. As water freezes, it expands, so it'll float. Tennis ball will float. Paperclip, even though it's really light, it's really small. So it's made of metal, right? So metal is typically pretty heavy per volume. So that has a high density, even though it's light to the feel. So it would sink. Okay. That is the conclusion of the density lesson.